So, Mantrika, in this lecture, we'll be understanding this table.
Okay.
And these are called allied angles. Allied angles. And what are allied angles? The definition of allied angles is what you have noted now.
Yeah.
If some or difference of the measures of two angles is either zero. So, for example, I have say I have a 30 degree, and
Mm.
again the other angle that I have is a 30 degree. So
Mm.
the difference of these two angles is 0 degree.
Yeah.
Okay. I have 90 degree, and the other angle that I have is 0 degree.
Mm.
90 degree minus 0 degree is 90 degree.
Yeah.
One angle is 180 degree, other angle is 0 degree. 180 degree minus 0 degree is 180 degree.
Mm.
If sum or difference of the measure of two angles is either 0 or an integral multiple of pi by 2. Integral multiple of pi by 2 implies that, see, integers are 0, 1, 2, 3, and so on, and minus 1, minus 2, minus 3.
Mm.
So integral multiple of pi by 2 would imply 0, pi by 2, 2 pi by 2, 3 pi by 2, uh, 4 pi by 2
Yeah.
on right hand side, and minus pi by 2, minus 2 pi by 2,
Mm-hmm.
minus 3 pi by 2 on the left hand side. Am I making any sense?
Yeah.
See, because you are a medical student, you won't be much concerned about the definition of allied angles. But I just
Mm-hmm.
wanted to tell you that if somebody asks you what are the trigonometric functions of allied angles, what are the ratios of allied angles, so this is
Mm.
what it means. This is the definition. So, for example, if I have two angles like say 30 degree and 60 degree, are they allied angles? Yes, they are allied angles because the sum of these angles are 90 degree. 90 degree
Mm-hmm.
is basically pi by 2.
Yeah.
If I have one angle 30 degree, other angle is 150 degree, do they constitute a allied angle? Yes, they constitute a
Yeah.
allied angle because the sum is 180 degree,
Degrees.
which is twice of pi by 2. Is it making sense?
Yeah.
So one of the angle is say one of the angle is 210 degree, other
Okay.
angle is 60 degree. The sum of
Mm.
the two angles is 270 degree.
270.
This is 3 pi by 2.
Yeah.
Is it making sense?
Yeah. Yeah.
So either the sum of the two angles or the difference of the two angles. So for example, one of the angle is 210 degree. The other angle is 30 degree. The difference of these is 180 degree. 180 degree is integral multiple of pi by 2. So these two, 210 degree and 30 degree, will constitute a pair which is called allied angles. Are you
Okay.
clear?
Yeah.
And I reiterate, you don't require the definition of allied angles because you are a
Mm-hmm.
medical student. But just to tell you, if somebody asks you what are allied angles are angles whose sum or difference is either 0 or integral
Mm.
multiple of pi by 2. And what is integral multiple of pi by 2? It is 0, 90, 180, 90,
270,
270,
360.
minus 90, minus 180, minus
Mm.
270. Yeah.
Okay.
So that is it. But our focus right now, focus right now is to understand what is the what is the meaning of this table. This is our main focus in this lecture.
Okay.
Any doubt?
No.
So basically, how we read this table is that if I ask you, how I read this table is how if I ask you what is cos 180 minus theta. If I ask you what is cos 180 minus theta, you should be able to tell me that this is minus cos theta. If I ask you what is tan, uh, let us say tan 270 plus theta. If I ask you tan 270 plus theta,
Okay.
you should be able
Minus
to
4
tell
theta.
that this is equal to minus cot theta.
Okay.
If I ask you what is cot 360 plus theta, you
Cot
should
theta.
it, you should be able to tell me that this is cot theta. Have you understood?
Yeah.
But then you will see the problem. You are intelligent enough to understand the problem. The problem is there are 6 rows and there
Hmm.
are 3, 6, 9. So we have 6 into 9. We have 54 entries.
Mm-hmm.
Do you think you would be able to cram 54 entries?
Little tough, but we'll have to do it.
Yeah. So the point is how to, remember these 54 entries
Mm-hmm.
as simply as is possible. So that, within 30 seconds, we'll be able to understand that what is the value of any of these 54 values. Have you understood what I said?
Yeah.
Now, before we start, one thing that you need to understand is, and very clearly understand is that whenever I talk about theta, the theta is
Mm-hmm.
the acute angle. Please
Acute
note this.
angle. Yeah.
Please note this down. That theta is acute angle. If you have noted, please note it again. Whenever I say 90 minus theta, whenever I say 90 plus theta, I say 360 minus theta, I say 360 plus theta.
Hmm.
270 plus theta, 270 minus theta. The theta is always acute. Please don't make any mistake.
Okay.
Theta will always be acute. And if you see, this table has been constructed in terms of minus theta, 90 minus theta, 90 plus theta, 180 minus theta, and in terms of, pi also, pi by 2 minus theta, pi by 2 plus theta, pi minus theta, pi plus theta.
Ah, okay. Yeah.
Yeah. Because, students coming from class 10th to 11th are more, comfortable with 270, 360,
Yeah.
180 rather than pi, 3 pi by 2, 2 pi.
Mm-hmm.
Initially you'll face a bit of resistance, but in the next 6 months it will be okay.
Yeah.
So basically, the focus of this lecture would be to understand how within 30 seconds we will be able to understand the value of any of these 54 values. Are we clear?
Yeah.
Okay. So now there is a bit of a background. We don't need to go much into the background. That will be a separate lecture. So don't worry
Okay.
about it much right now.
Hmm.
But these are the one, two, three, four, five, six identities that you'll have to cram.
Hmm.
Now, of course, you can ask me how these are derived. That is again none of your business. So just cram these 6 identities, and they are pretty simple. I'll tell you the logic, and you'll once you understand the logic, you'll understand it is pretty simple. So it is
Okay.
sine a plus b.
Hmm.
So whenever the identity is in terms of sign, so it will be sine a cos b, cos a sine b, and there is just a difference of sign between these two.
Mm-hmm.
A plus here and a minus here. Did you see this?
Okay. Yeah.
Again, if you take the identity of cos and cos a minus b,
Hmm.
now the cos is cos a cos b, sin a sin b, cos a cos b, sin a sin b. But now the signs are inverse. When there is a
Hmm.
plus here, there is a minus here. When there is a minus here, there is a
There's a
plus here,
plus. Yeah.
which doesn't happen in the sign. When there was a plus, there was a plus, there was a minus, there was a minus. Have you understood?
Hmm. Yeah.
So basically, when the identities are for sign, then the group is sin cos. If the identity is for cos, it will be
Person.
cos cos, sin sin. Have you understood?
Yeah.
So 1, 2, 3, 4.
Hmm.
Now, if you look at tan a plus b, somehow tan a plus b, if you look closely, it follows the logic of this sin a plus b. So it is tan a plus tan b upon 1 minus tan a tan b. And when
Hmm.
there is a tan a minus b, then this negative will come in the numerator and the opposite will come in the denominator. Is it making sense?
Yeah. Yeah.
Now, these 6 identities we need to cram because in one of the lectures, maybe the next lecture or after that lecture, we'll be
Hmm.
starting from these 6 identities and then we'll be deriving few results.
Okay.
So these have to be crammed. But
Okay.
right now, why I want to discuss these identities to uh, tell you how these values of allied angles can be derived.
Hmm.
Okay. So for example, uh, let me say that I want to find the value of say sine minus theta. Yeah. Now
Okay.
I can write sine minus theta as sine 0 minus theta. Have you understood what I've done?
Yeah.
And then sine 0 minus theta can be written as sine 0 cos theta plus cos 0. I'm sorry,
Yeah.
minus
Yeah.
minus cos 0 sine theta. Have you understood what I've done?
Yeah. Yeah. Yeah.
Basically, I have used the second identity.
Yeah.
Now I know sine 0 is 0, so this becomes 0.
Hmm.
And I know cos 0 is 1, therefore this becomes
Yeah.
minus sine theta.
Okay.
So using the identity, I know that sine of minus theta is equal to minus sine theta.
Yeah.
Avadika, have you understood?
Yeah.
Similarly, if I want to derive say value of cos minus theta, then
Hmm.
cos minus theta can be written as cos 0 minus theta. Cos
Hmm.
0 minus theta, I'll be using the fourth identity.
Yeah.
This will be cos 0 cos theta plus sine 0 sine theta. Have you understood?
Yeah.
Now sine 0 sine theta would be 0. Why? Because sine 0 is 0. Cos
Yeah.
0 is 1. So this would
Hmm.
be equal to cos theta.
Okay.
Cos of minus theta is equal to cos theta. Have you understood what I said?
Yeah.
Now, this first column of minus
Hmm.
theta.
Hmm.
This is how the value of this column can be calculated using the six identities. Have you understood now?
Yeah.
Now let us take another example. Let us take example of say 90 plus theta. 90 plus theta.
Okay.
So for example, I want to derive sine 90 plus theta.
Hmm.
So what will I do? I will use this identity.
Yeah.
I will say sine 90 cos theta plus cos
Plus
90
90.
sine
90.
theta.
Yeah.
This is 1.
Yeah.
This is 0.
Yeah.
This would be cos theta. So sine 90 plus theta is equal to cos theta.
Plus
Have you-
theta. Yeah.
So let us look at the table. Sine 90 plus theta. Sine Sine 90 plus theta is equal to cos theta.
Plus
Have you
theta.
understood?
Yeah.
Any doubt?
No.
So now again, one of the very simple thing that you need to understand is that if sine 90 plus theta is
Hmm.
equal to cos theta, then what about cosecant 90 plus theta? Have you understood? Now cosecant 90 plus theta is anyways 1 upon sine 90 plus theta. Have you understood?
Yeah. Yeah.
And I know I have calculated that sine 90 plus theta is cos theta, so this would be 1 upon cos theta. And 1 upon
Hmm.
cos theta is secant theta. So that is
Yeah.
why cosecant 90 plus theta. Cosecant 90 plus theta is equal to secant theta. Have you
Second.
understood?
Okay. Yeah.
So the point is, let me reiterate, these three can be calculated using the six identities,
Yeah.
and these three can be calculated using the results of the above three. Have you understood?
Yeah. Yeah.
Okay. Now again, again, this would be something that we will be discussing in the coming lectures, maybe
Okay.
in the next one or two lectures. But just for understanding sake, just for understanding sake,
Hmm.
right now you'll just have to take my word on this. But
Okay.
in the next one or two lectures, we'll discuss this in detail.
Okay.
So this is how the graph of sine theta looks like.
Hmm.
This is how the graph of cos theta looks like.
Okay.
And just take my word on this, and in the next few lectures, we'll discuss this also.
Okay.
So, I will share the lecture also where in detail I have discussed this.
Mm-hmm.
But right now, just assume that whatever am I saying is correct. Okay. So, this is 0, this is 90, this is 180, this is 210. Oh, I'm sorry, this is 270,
70.
this is 360.
Hmm.
This is 0, this is 90, this is 180, this is 270, this is 360. Now, how the readings are taken is that this is the maximum value of sine, which is 1. This is the
Mm-hmm.
minimum value of sine, which is minus 1. Similarly, for cos, this is the maximum value, which is 1, and this is the minimum value, which is minus 1.
Okay.
Have you understood what I've said?
Yeah.
So, in one of the lectures, if you remember, I told you that sine can only take values between 1 and minus 1. Similarly, cos can only take values between 1 and minus 1.
Yeah.
So, this is how this graph of tan theta looks like, roughly like this. So, this would be 90, this would be 180, this would be 270, this would be 360. Have you understood?
Okay. Yeah.
Now, why I wanted to discuss this, I'll just tell you in a second. So, you can refer to this graph, and
Mm.
I'll tell you why you will need to refer to this graph. Because once we refer to this graph, we can find the values of sine 90,
Mm.
180, 270, 360 very easily. Why? Because sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, and sine 360 is 0. Have you understood?
Yeah.
Similarly, cos 0 is 1, cos 90 is 0, cos 180 is minus 1, cos 270 is 0, and cos 360 is 1. Have you
One.
understood?
Yeah.
Uh, tan 0 is 0, tan 90. This is called asymptote. What exactly is an asymptote? We won't discuss it now, but for future references, this,
Mm-hmm.
what, this line is this line is called asymptote. We'll discuss this. Don't worry. But what
Okay.
this means is that at tan 90, the
Mm.
value of tan goes to infinity, and they call this as not defined. Have you understood what I've said?
Yeah.
So this is 90, this is 180. So tan 180 would be 0.
Mm.
Again at tan 270, it will be not defined, and tan
Yeah.
360 would again be 0. Any doubt till here?
No.
Okay. Now, another thing that I want to discuss maybe won't make sense now, but still, because we are discussing the graphs, just let me spend 2 minutes on this also.
Yeah.
If you remember our all sine tan cos, you'll remember that
Yeah.
0 to 90 all sine. If you see the first and second quadrant, they are positive for sine, but
Hmm.
the third and fourth quadrant are
Hmm.
negative for
Yeah.
sine. Is it making sense?
Yeah.
Similarly, if you see the graph of cos, all sine, tan, cos. In the first and fourth quadrant,
Hmm.
cos is positive. But in the
Mm-hmm.
second and third quadrant, cos is negative.
Yeah.
Now, similarly, if you see the graph of tan, this is all, this is sine, this is tan, this is cos. So here tan is positive, here tan is positive in the first and the third quadrant, and it
Mm-hmm.
is negative in the second and the fourth quadrant.
Okay.
Are we clear till here?
Yeah.
These are the graphs of sine, cos, tan. They will
Hmm.
help you to
Okay.
find the value of sine, cos, tan at 0, 90, 270, and 360.
Okay.
And we will discuss this in detail, don't worry. In the coming
Okay.
lectures, we'll discuss in detail. Now, why would you require this graph? You would require this graph because your homework for today would be to prove each of these values. Basically, what you'll have to do is you'll have to take these three columns
Hmm.
and prove each of the value. So, for example, you'll have to prove that sine minus theta is minus sine theta. You'll have to prove
Okay. Okay.
sine 180 plus theta is minus sine theta.
Okay.
Sine 270 plus theta is minus cos theta. Sine 360 plus theta is plus sine theta. Have you understood?
Yeah. Yeah.
Now, I'll tell you the difficulty that you will face. The difficulty that you will face is, for example, you are calculating sine 270 minus theta. Sine 270 minus theta.
Hmm.
So, when you are calculating sine 270 minus theta, you will understand that the identity that you will have to use is sine A minus B.
Yeah.
So, sine A minus B equal to sine 270
Hmm.
cos theta minus cos 270 sine theta. Have you understood what I've said?
Yeah.
Now the problem is, how do you find the value of sine 270 and how do you find the value of cos 270? Have you understood the problem?
Okay.
Have you understood the problem?
Yeah.
And now the graph that I have shown you would help you. How will it help you? Sine 270, sine graphs look like this.
Yeah.
So this is 90, this is 180, this is 270. So sine 270 is minus 1. So you will
Yeah.
write here minus 1. This would be cos theta minus cos 270. The
Hmm.
cos graph looks like this.
Yeah.
This is 90, this is 180, this is 270. Cos 270 is 0, therefore this would be 0. Therefore this would be minus cos theta. One thing, have you understood what I've said?
Yeah. Yeah.
So the point that I'm trying to make is that for proving the values of
Hmm.
our right angle table,
Yeah.
you will require the value when you were trying to prove, you will require again and again the value of
Hmm.
say sine 270, you'll require value of cos 270, sine 360, cos
Hmm.
360, tan 270. So when you are requiring the values, you can refer to these graphs. I will share
Yeah.
these graphs with you.
Okay.
Any doubt till here?
No.
Okay. So what have we discussed till now? What we have discussed is that we want to know first is that these are the allied angles. Second
Hmm.
thing that we discussed was that these are 54 values, and the first job would be to prove that how this table is constructed. To
Hmm.
prove how the table is constructed, you need these six identities plus the graph that I have shown you, so that you have the value of each and 0, 90, 180, 270, 360. You have all.
Hmm.
Have you
Yeah.
understood?
Yeah.
Then, so 0, 90, actually I should write here 180 and 260 also. Yeah, 180. So you'll require the value of sine 270, sine 180,
Hmm.
sine 360. You'll require the values of cos, you'll require the values of tan. So you can refer to these three graphs. So you'll
Yeah.
easily get the values. Okay.
Yeah.
Once you have, so that this is what will be your homework, and that is what I was trying to tell you, that this would be taking you say maybe 2 to 3 hours.
Okay.
Just focus on these three columns first, because we know that once we have derived the values of the
Hmm.
first three columns, then the rest of the three columns, sorry, three rows, the rest of
Hmm.
the three rows are just the reciprocals of the first
Yeah.
three rows.
Yeah.
Any doubt in there?
No.
One second. Phone like this. Phone like under that. Okay. Okay. Once we are okay till here, okay, so the homework would be to prove all the allied angles. And now
Yeah.
what we need is a trick to remember these 54 values. Yeah?
Yeah.
Okay. Now we come to the trick. And the trick is something like this. Okay. The first is, we remember this quadrant, the ATC quadrant,
Yeah.
all sine, tan, cos. Do we understand this well?
Yeah.
So the mnemonic can be after school to college, or it can be add sugar to coffee, or it can be all science teachers are crazy. So using this mnemonic devices, we understand that how do the signs of the how do the signs of various trigonometric functions vary. So
Hmm.
here sine, cos, tan and their reciprocals are positive. Here only sine and its reciprocal cosecant is positive. Here only tan and cot is positive on the.
Mm-hmm.
Hmm. Okay. All sine, tan,
Yes.
cos, cos
Hmm.
and secant. So here everybody is positive. Everybody
Hmm.
is positive. Here only sine and cosecant are positive. Here only tan and cot are positive. Here only cos and secant are positive.
Yeah.
So if sine, now it goes without saying that if only sine and cosecant are positive, then rest of the people, that cos, secant, cot, tan, all of
Yeah.
them are negative.
Yeah.
Are you clear about this, Avantika?
Yes.
Okay. So this is the first thing that we need to understand, and that is why
Hmm.
we did a small revision. That
Mm-hmm.
in the first quadrant, these people are positive, and second, these are positive, and in the third quadrant, these are positive,
Mm-hmm.
and in the fourth quadrant, these are positive. Are we clear till
Yeah.
here?
Yeah.
Okay. The second thing that we need to remember is the second thing that we need to remember so that we understand the trick well is that this is 0, this is 90, this
Hmm.
is 180, this is
Mm-hmm.
270.
Hmm.
Theta would always be acute. Theta is always acute.
Yeah.
Okay. So this would be my theta.
Okay.
If I do a 90 minus theta, the 9 because theta is acute, 90 minus theta will always be acute. Have you understood what I'm saying?
Yeah.
So, for example, if theta is 30 degrees, 90 minus 30, 60 degrees would always be in first quadrant.
Yeah.
So, 90 minus theta would always lie in the first quadrant. Are we clear till here?
Yeah.
Similarly, 90 plus theta would always be in second quadrant. Are we clear till here?
Yeah.
Similarly, 180 minus theta would always be in second quadrant. Are we clear?
Yeah.
Because again, if theta is 60 degrees, then 180 minus 60 is 120 degree, 120 degrees in the second quadrant.
Yeah.
Similarly, 180 plus theta
Hmm.
and 270 minus theta
That's
would
theta.
always be in the third quadrant.
Third quadrant. Yeah.
And 270 plus theta and 360 minus theta would be in the fourth quadrant.
Fourth quadrant. Yeah.
Actually, 360 plus theta would also always be in the first quadrant.
Yeah.
Are we clear till here?
Yeah.
So, we have 0, we have theta, we have 90 minus theta, we have 90 plus theta, we have 180 minus theta, we have
Hmm.
180 plus theta, we have 270 minus theta, we have 270 plus theta, we have 360 minus theta. As
Yeah.
a part of it, I can also write minus theta here. Are we clear till here?
Yeah.
Okay. Now, why I wanted to show you this was because when I construct my allied angles table, I
Hmm.
can write the values like this: minus theta, 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 270 minus theta, 270 plus theta, 360 minus theta. So I can construct my table like this.
Hmm.
So now compare this table with the
Hmm.
table that we had started with,
Hmm.
this table.
Yeah, yeah.
So if you see, one thing, just give me a second here. Just give me 1 second.
Yeah.
So now when we again look at this table, let us make sense of this table again. So when you look at minus theta, you know you are in the fourth quadrant.
Yeah.
When you look at 90 minus theta, you know you are in the first quadrant.
Quadrant.
When you look at 90 plus theta, you know you are in
Second
the second quadrant. 180 minus theta, second quadrant.
quadrant.
180 plus theta, third quadrant.
Third
270
quadrant.
minus theta, third quadrant. 270 plus theta, fourth quadrant.
Fourth
360
quadrant.
minus
360
theta,
minus 6.
fourth quadrant.
Fourth.
360 plus theta is first quadrant. Is
First
it?
quadrant. Yeah.
So there is some semblance of, some sanity now
Hmm.
that, slowly we are understanding how the table works. Okay.
Hmm.
Now is the most simplest thing that now there are, two ways in which you can remember. The first way of remembering the values is that, for example, you have sine, you have, say, okay, let us say you are asked what is sine 180 minus theta, or you are asked what is sine 180 plus theta, or you are asked what is cos 180 minus theta, or you
Hmm.
are asked what is cos 180 plus theta.
Yeah.
Okay. Now, this is the first question which is asked.
Hmm.
These are the four values they asked in the first question. In the second question, they ask you values like what is the value of sine 90 minus theta? What is the value of sine 90 plus theta?
Hmm.
What is the value of cos 90 minus theta?
Hmm.
Uh, what is the value of cos 90 plus theta? Yeah. Okay. So let us look at the simple. Let us look at the simple one first. So sine 180 minus theta. Whenever they asked you anything regarding these values, say 0 minus theta,
Hmm.
or 0 plus theta, or 180 minus theta, or 180 plus theta, or 360 minus theta, or 360 plus theta.
Hmm.
Whenever whenever these kind of identities are asked, say for sine, cos, tan, it hardly matters. Cosecant, secant, cot, it hardly matters.
Hmm.
Whenever they'll ask you what is sine 0 minus theta, what you need to remember is that sine would remain the sine on the right hand side. But depending upon which quadrant you are, so for example, sine minus theta, you are in the fourth quadrant. So the value of sine in the fourth quadrant is negative. That is why this would be negative. Does it make any
Okay.
sense?
Yeah, yeah.
I'll be taking a lot of examples, don't worry.
Hmm.
So sine 180 minus theta, sine 180 minus theta.
Hmm.
Because it is 180, sine would remain sine.
Yeah.
180 minus theta. 180 minus theta is in the second quadrant. In
Second
second
quadrant.
quadrant, sine is positive.
Positive.
Therefore, this would be positive of sine
Positive.
theta.
Yeah.
Any doubt?
No.
Cos 180 plus theta. Because it is 180, cos would remain cos.
Hmm.
But cos 180 plus theta, in which quadrant does 180 plus theta fall? 1, 2, 3.
Third. Third.
All sine tan. Cos is negative. Therefore, this
Negative. Okay.
tan 360 minus theta. Because it is one of the values 0, 180, 360. Whenever
Hmm.
you will see 0 plus minus theta or 180 plus minus theta or 360 plus minus theta,
Hmm.
whatever is the function on the left hand side, the function would be the same on the right hand side. Don't worry about the function. Just worry about the sign of the function. So what this implies is that tan 360 minus theta, tan would remain tan.
Hmm. But negative.
360 minus theta, all sine tan cos. We are in the fourth quadrant,
Third
all
quadrant.
sine tan cos. But this is negative. Any
Negative.
doubt? Any doubt?
No. No.
So whenever the values are 0 plus minus theta,
Hmm.
180 plus minus theta, 360 plus minus theta. So sine would remain sine, cos would remain cos, tan would remain tan.
Hmm.
And they are reciprocals.
Okay.
That is, cosecant would remain cosecant, secant would remain secant, cosecant would remain cosecant. So for example, cosecant 180 minus theta. Cosecant would remain cosecant because there is a 180 degree. So
Hmm.
secant theta. I need to worry about the sign. But where is 180 minus theta? 180 minus theta is in the second quadrant
Second
or
side.
sign. Cosecant is positive. So this would be positive cosecant theta. Any doubt till here?
No.
Okay. Now let us look at the other values. When we face 90 plus minus theta or 270 plus minus theta,
Hmm.
sine will change into cos will change into sine, and tan will change into cot, and cot will change into tan. Any doubt there?
No.
Okay, let us take few examples and try to understand. So for example, I have sine. Of course, they will change, but the second principle that we use of sine, the sine will be given by all sine tan cos only. All sine tan cos only. Let me show you with this example. So for example, sine 90 plus theta. Tan 90, tan 270 minus theta. Cos 90 minus theta.
Hmm.
Cos 270 plus theta. I will just add here that cosecant will change into secant and secant will change into cosecant. Okay, let us take examples. So sine 90 plus theta. Sine, because there is a 90 here, sine will change into cos theta. 90
Hmm.
plus theta is in the second quadrant. In second quadrant, sine is positive.
Positive.
So this would remain as positive. Does it make sense?
Yeah.
For sine, you always have to take the value of the function on the left hand side,
Hmm.
not on the function on the right hand side. This is a common confusion.
Okay.
Is it making sense?
Yeah.
Let us take more examples. Tan 270 minus theta. Because there is a 270 here, my tan will change into cot.
Out.
270 minus theta. I am in the all sine tan.
Third quadrant.
Third quadrant. In
Yeah.
third
So
quadrant,
tan.
tan is positive.
Yeah.
So this would be positive.
Okay. Yeah.
Let us take cosecant 270 plus theta.
Okay.
Cosecant 270 plus theta.
Fourth
Because
quadrant.
270, cosecant will change into secant.
Second.
Cosecant 270 plus theta. I am in the
Fourth quadrant.
fourth quadrant. Fourth quadrant, cosecant is negative.
Negative.
So this would be minus secant theta. Is it making
Yeah.
sense?
Yeah.
Cos 90 minus theta. Because of 90, cos will change into sine.
Hmm.
90 minus theta. I am in the first
First.
quadrant. Why? Because my theta is an acute angle. That is why this
Mm-hmm.
is plus sine theta. Is it
Plus.
making
Yeah.
so cos 270 plus theta. There is a 270 here, so my cos will change into sine.
Hmm. Fourth
270,
quadrant.
yeah, 270 plus theta. I'm in the fourth quadrant. All sine tan
First
cos.
is positive.
So this would be plus sine theta.
Okay. Yeah.
Does it is it making any sense now? So this is how you can remember. No change when crossing 0, pi or 2 pi. So for example, if you are crossing 0, pi, 0, pi or 2 pi,
Hmm.
so whenever the angles are, so for example, pi plus theta or pi minus theta, or whenever
Hmm.
the angles are 0 plus theta, 0 minus theta, or 2 pi plus theta, 2 pi minus theta. So
Mm-hmm.
there would be no change in the function. Sine would remain sine, cos would remain cos, tan would remain tan.
Okay.
But whenever you are changing into 90 or 270, so for example, 90
Hmm.
plus theta, 90 minus theta, 270 plus theta, 270 minus theta, then sine will change into cos, cos into sine, tan to
Mm-hmm.
cot, cot to tan, secant to
Okay.
cosecant, cosecant to secant. Is it making sense?
Okay. Yeah.
And then you have to look at the function on the left hand side
Hmm.
and match it with the quadrant to find the sign which you should put on the right hand side. Is it making
Hmm.
sense?
Yeah.
So, for example, now let us try to see whether the table that we have drawn is it making sense or not.
Hmm.
So, so let us take any random value tan 360 minus theta. So tan 360 minus theta. So tan 360 minus theta.
Hmm.
There is a 360. So tan
Yeah.
would remain tan.
Tan.
360
Fourth
minus a
quadrant.
yeah 360 minus an acute angle. So
Hmm.
acute angle might be 30. So I am in the fourth quadrant.
Hmm.
All sine tan cos. Tan is negative.
Yeah.
So this would be negative. So this would be minus tan theta. So tan
Mm-hmm.
360 minus theta should be equal to minus tan theta. Is it making sense?
Yeah.
Let us take another example. Cos 270 minus theta. So cos 270 minus theta. There is a
Hmm.
270. So cos will change into
Fine.
sin. 270 minus an acute angle. You will be in the
Uh,
third
third quadrant.
all sine tan.
Hmm.
So cos would be negative in the third quadrant. So this would
Yeah.
be minus sin theta.
Okay. Yeah.
So this would be minus sin theta.
Yeah.
Any doubt?
No.
Let us take a few more examples. So for example, tan 270 plus theta.
Hmm. Okay. As it's 270 changes to cot and 270 plus theta lies in fourth quadrant and is negative.
Is it making sense?
Yeah.
So that is why you see here. That is why you will see here minus cot theta here.
Yeah.
Any doubt?
No.
Now the important thing to for you as a medical student is to understand how this table works. That you have understood.
Hmm.
Yeah.
Yeah.
But we need to we also need to understand how these identities work.
Yeah.
So that is why I am telling you that just use these identities
Hmm.
to calculate and verify the values of
Yeah.
these three rows,
Hmm. Hmm.
sine, cos, tan, for
Hmm.
all these
Yeah.
values. So that once you have practiced 27 times,
Hmm.
9 3 the 27, you will remember these six identities. Any doubt?
No.
So tomorrow, when we meet,
Hmm.
we'll spend some time in understanding these graphs,
Okay.
and we need to spend some time to to discuss these results. I'll show you the results that we need to discuss.
Okay.
Uh, Once again.
Yeah.
Hmm. We will need to see using these identities. The identities that we would be using would be these identities of sine, cos, tan. These would be the six identities that we will be using. And using these identities, we'll try to understand sine to theta, cos to theta, tan to theta, sine 3 theta. This would be cos 3 theta, tan 3 theta. These six identities. Then we'll understand these sine c plus d, cos c plus d. We'll understand 2 sine a, sine b. Now you might be thinking and you might be wondering, why do you require these in physics? But you need to trust me on this for some time, that yes, of course, you will require these in physics.
Okay.
You want the name of the chapter. So, for example, this 90 minus theta, 90 plus theta, this would be mostly used in SHM. And these identities, whenever we meet waves, will meet waves in sound and in light. So, whenever we meet waves, we'll be using identities like these. Have you understood?
Okay. Yeah.
So, this is the agenda for the next lecture. So, let's meet tomorrow at 11. Have you
Yeah.
understood your homework?
Yeah. Yeah.
Okay. Okay. So, let's meet tomorrow at 11. Yeah?
Yes.
Okay.
Thank you.
Okay.